Hi, welcome to solveandgo.com. This is the next solution in a series of video solutions to the Math 186 final exam from 2005. This is question number 10. This question is about work. So the setup is we have a cone. Let me draw it here. So we have a cone with radius r and height h. And there's a liquid inside. Okay, so think of it being filled with liquid. Okay, and the density of the liquid, so the liquid density equals this number rho, so that's just some constant, kilograms per meters cubed. Okay, so then the question is to find the work done in pumping out the top 1 over 2h, so the top half of the liquid, meters of the liquid. Okay, so that's the question, the work done to pump out the top half meters of the liquid. Okay, so let's put in some variable names here. At time t, we'll let the radius be called x, so the radius of the top of the liquid will be x, and the height of the liquid will be y. Okay, so the radius is x of t, and the height will be y of t. Okay, so what we know is that work is force times distance. So what distance are we moving at a given time? Well, it's going to be the height of the cone minus the height of the water. So the distance moved at time t, so it's the distance we're moving the liquid to get it over the top, is going to be h at time t is going to be equal to h minus y at time t. So what's the area of this circle at time t? Well, it's going to be pi times x squared. Okay, so now we know the distance moved at time t. What is the force required at time t to move a given portion of water? Well, let's look at a really small cross-section of the water that we need to move. Okay, so it's like a slice. It'll form a disc, a slice of the water. Okay, so I'll leave our work formula there. And so the force required is going to be equal to the weight of the water. Okay, so how do we get the weight? Well, we get the mass and we multiply it by 9.81, or the constant g. Okay, so let's take a look. If we take a cross section of water, it'll form a disk. We want to find out what the volume is, and therefore, given the density, we can get the mass of a small slice of this water. So delta y will be the small change in height, and then x will be the radius at time t. So at a given time t, we have delta y and x. And so the volume is pi x squared times the height, which is delta y. So that's the volume of a small little disk of water. Okay, of height delta y and radius x. And so then the mass is given by the volume times the density. times this number rho. So you can check it out. The meters, the units tell you this is true. Kilograms per meters cubed times volume, which is meters cubed, give you kilograms. So that's the mass. And then the weight should be this times g. So it's g times rho times pi x squared delta y. Okay, so that's the weight of a small disk. Okay, so keep that in mind. And so the work done, so the work in moving a small disk equals, so it was pi rho g x delta pi x squared delta y. Okay, so we want to add up all these small little disks, which is the same as integrating. Okay, this is what integration does for us. Okay, so the total work will be, now the integral, and we want to go from, so we're integrating over the height. Y is what's changing. Well, so is x, but we're taking small changes in y, delta y. So we're integrating with respect to y. So we want to integrate this. So it's force times distance. Okay, so what distance are we moving? So we already saw that was h minus y. So we integrate rho g pi x squared times h minus y dy. And we go from h, so when it's completely filled, to when it's halfway filled. So it's h to h over 2. That's the integral. Now, y is not the only thing changing with time, so is x. So right now we have a function of two variables under the integral sign. We want to change that and make a function of one variable. Okay, so let me erase this and write up our integral. It was the integral from h to h over 2 of pi times rho times g times x squared dy. Okay, sorry, we need to multiply by the change in height as well, which was h minus y. Okay, dy. So you're thinking of this as force times distance. Force here times distance here, and then you integrate. Okay, so let's see. We need x in terms of y. We're going to use similar triangles. So what we have over here, if you take a piece of this cone out, we know that it has height h and radius r. And at a given time, this value is y, and this value here is x. And so what we get from here is that h over r is y over x. And so we want x in terms of y. We get x equals ry over h. Okay, let me make that a little clearer. That's an r. So now our integral becomes the integral of, so let me factor out the constants. Pi, rho, and g are all constants. We integral from h to h over 2 of x squared, so that's r squared y squared over h squared times h minus y dy. Okay, so that's our integral, and now we just evaluate that. So let me erase everything, and our job now is just to take the integral. So we'll do that. We have pi rho g times the integral from h to h over 2 of r squared y squared over h squared times h minus y dy. Okay, and this is a little bit of a calculation. We'll see what we can do here. So step 1 is to separate this into two integrals. We get pi rho g times the integral from h to h over 2. We're going to split up this fraction. It ends up being r squared y squared over h dy. minus the integral from h to h over 2 of r squared y cubed over h squared dy. And then again, we're going to factor out all the constants. So we can factor out, we have pi rho g times, here we have r squared over h as a constant. We integrate from h to h over 2, y squared dy minus r squared over h squared, the integral from h to h over 2 of y cubed dy. Okay, so we're further simplifying our integral. And then what do we get next? Well, we now take the integral. So we have pi rho g times r squared over h times y cubed over 3 from h to h over 2 minus r squared over h squared times the integral of, so times y4 over 4 from h to h over 2, which will give us, let's see, I'm going to have to erase what's up here. We get pi rho g times r squared over h times, so h over 2 cubed times 3. So that's h cubed over 24 minus h cubed over 3 minus r squared over h squared times, so we get h4 over 64 minus h4 over 4. And now we're in pretty good shape. We just need to simplify what we get here. So it's pi rho g r squared over h times, so this ends up being negative 7h squared over 24 minus r squared over h squared times plus, so we're going to put a plus here, and this will make this plus, let's leave it as a minus. This is minus 15 h squared, h to the power 4 rather, over 64. And then canceling factors, we get rho g times negative 7h squared. Careful. Okay. This is an h cubed. Okay, we're good. So we get negative 7h cubed h squared, r squared over 24. We have to be careful here. Minus, plus, minus and minus makes a plus, 15 r squared h squared over 64. Okay, right. Which ends up being, if you factor everything out, let me erase what's on the bottom here, ends up being pi rho g, there's an h squared, r squared in each of these, times negative 7 over 24 plus 15 over 64, which finally gives us 11 over 192 when you actually end up calculating this fraction, times pi rho g h squared r squared. Okay, so that's the solution to question number 10, a little bit more involved. That was not a tricky integral, but there were a lot of variables and constants to keep track of. So just make sure you do it carefully, and this is the procedure you should follow.